Hi, my name is Curtis Wilkerson, and this video is going to be my presentation for the BIO182 video presentation assignment. The topic that I'm going to be discussing is Mendelian genetics, so let's get right into it. The first article that I read was from the New York Times, and it was titled, "What's Behind Many Mystery Ailments? Genetic Mutations Study Finds." So let's begin with the summary. Long after the death of Gregor Mendel in 1884, it was discovered that some diseases can be considered Mendelian because they're inherited. By now, scientists have discovered over 7,000 Mendelian diseases through screenings of adults and children, but a recent study shows that many of these diseases are left undetected. Mendelian genetics has provided a foundation for researchers to determine the cause of diseases that have unknown origin. Through a database of electronic health records, it was found that 3.7% of patients within the hospital system carried a genetic link to a disease. This indicates that potentially 4.5% of previously considered non-genetic diseases could actually be linked to genetic mutations. A recent study actually found that there are 807 patients that have mutations in genes that are linked to 17 different diseases. A small number of these patients had actually gotten tests that revealed the mutations. However, all of the other ones were either misdiagnosed or never received genetic testing. It's hypothesized that one defective copy of a gene may cause milder versions of Mendelian diseases, and overlooking the genetic causes of these diseases could cause patients serious harm. Luckily, the study implemented was very effective in identifying the cause of diseases. This study and this experiment relates our knowledge of Mendelian genetics with an application to the real healthcare field. The lay article can be considered accurate because it was developed from a team of scientists that worked effectively at identifying these causes of unknown diseases. Moving on to the summary of the primary research article. The article that I read was titled, "Phenotype Risk Scores Identify Patients with Unrecognized Mendelian Disease Patterns." Now, a phenotype risk score is a common scientific method used to detect Mendelian disease patterns using the phenotypes from the electronic health record. Typically, studies of genetic association examines features individually. This often leads to the overlooking of subpopulations that have more than one phenotype sharing a single cause. This study derives an approach that organizes the phenotypes based on patterns described by Mendelian genetics. The scientists within this study were able to map the clinical features of 1,204 Mendelian diseases into phenotypes captured by the electronic health record. Then, they summarized this evidence using phenotype risk scores. Applying these phenotype risk scores found that 21,701 genotype individuals showed 18 associations between rare diseases and phenotypes that are correlated with Mendelian diseases. The significance of this finding is that diseases may be more commonly inherited according to Mendelian genetics than we once thought. Moving on, we're going to take a quick look at a figure. This figure shows the diagnostic fingerprint of Mendelian disease in electronic health record data. The first box plot shows cystic fibrosis, next Marfan syndrome, the next achondroplasia, followed by hemochromatosis, Li-Fraumeni syndrome, and phenylketonuria. The accuracy of this study can be confirmed by 32 sources of reference, along with a complex scientific team with multiple credentials.